Hello everybody, welcome back. Today we are going to do the final part of Unit 1, Subunit 1.8, which is all about valence electrons and ionic compounds. This will be a very short lesson, so have your periodic tables out and let's get started. So we've talked about this before, but I am just reminding you how we know how many valence electrons elements have, and everything in group 1 has 1, all the alkaline earth metals have 2. We sort of skip the transition metals, most of those have 2. There are some exceptions, but group 13 is 3, 4, and so on and so on. Okay, we've already gone through that before. What I want to make sure that you all know is that since elements in the same columns have the same number of valence electrons, that means they will have the same electron configuration, and thus, because they have the same electron configuration, same number of valence electrons, they will have similar properties. Elements in the same column have similar properties. That's why they're called families. Okay. So be aware of that, for example, sodium chloride and sodium bromide are compounds that will behave not exactly the same way, but similarly, because each compound contains a halogen. Okay. Now, because we know how many valence electrons each family has, we also will know the most common ion charges for elements in each family. For example, when elements in group 1 become ions, they are 1+ ions. Group 2, they're 2+. Your transition metals, if you'll remember from Chem 1, can carry multiple charges. So I didn't label those. Group 13, those are 3+. Group 14, carbon itself typically does not gain or accept electrons, but things in group 14 can kind of go either way. Nitrogen's families, typically 3-, and so on and so forth. So if you all remember those charges, then it's very easy to predict ionic compounds. So I want you just to look at this question. This is pulled directly off of an AP exam. So I want you to read through it, or I'll read through it with you, and then I want you to try to answer it. It says an element X has the electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. If this element were combined with calcium, what would be the ionic formula? So I want you to pause and see if you can come up with the answer. All right, let's see how you did. Hopefully you all looked at that configuration and figured out that element X is the element chlorine. Chlorine typically carries a -1 charge when it becomes an ion. So if we're going to combine that with calcium, which carries a +2 ion, it's going to be, you can answer it either way. You can say that the ionic formula would be CaX2, or you could write CaCl2, either one. So those are some kind of questions that you could see. So that concludes subunit 1.8 and all of unit 1. So I want to congratulate you for finishing your first whole unit in AP Chem. I hope you learned a little something today and in previous days that you've been watching these lessons. And I look forward to seeing you for Unit 2.